Looking up at a clear night sky, it is easy to assume you are looking at a quiet, static expanse. That stillness is a trick of perspective. We are separated from those stars by thousands of light years, a distance so vast it masks the catastrophic physical reactions taking place across the void. NASA astronomers have documented these environments in a collection called the Galaxy of Horrors. These are observed empirical destinations where the standard laws of physics are pushed to their breaking point. We are investigating the mechanisms behind these extremes to see what happens when heat, radiation, and gravity are amplified to their most destructive levels. By looking past the tranquil surface of the night sky, we find a universe defined by the active, structural destruction of its own matter. This destruction begins at the planetary level, where thermodynamics and weather transform atmospheres into lethal environments. This simulation shows the conditions on the exoplanet HD 189733b. The winds here reach 5,400 miles per hour, dragging relentless storms of actual shattered glass completely sideways across the planet. Some worlds, like HD 80606b, experience violence on a schedule. As this diagram tracks its highly elliptical orbit, watch the planet as it swings close to its host star. That brief approach triggers supersonic shockwave storms that rip across the entire surface. Then there is TRES 2b. This planet absorbs almost all starlight, making it darker than coal, yet the air itself is hot enough to glow. The red tint at the edges shows an atmosphere as hot as lava. In these systems, an atmosphere does not act as a protective layer. It functions as a volatile, high-pressure cooker. While planetary weather is destructive, the stars themselves produce a much more consistent threat: sheer radiation. A young star like AU Microscopii continuously torments its newly formed planets with blasts of X-ray flares, preventing any chance of atmospheric stability. This diagram shows a pulsar, the rapidly spinning core of a collapsed star. It sweeps the area with concentrated radiation beams. Planets trapped in these orbits, like Poltergeist and Phobator, are zombie worlds, rocky, barren bodies slowly consumed by constant exposure. Some planets even endure a journey inside a star. Kepler 70b spent time within the expanding outer layers of its host before it died, leaving the planet with a surface temperature of roughly 12,000 degrees Fahrenheit. These stars are not just sources of light, they are radiation engines that eradicate the potential for life in their vicinity. On a macro scale, the fate of entire solar systems is dictated by two invisible forces: crushing gravity and dark energy. You can see the mechanical power of tidal gravity acting on the gas giant WASP-12b. The pull from its host star is so intense that it is physically stretching the planet into the shape of an egg. Scale that force up to a black hole like Cygnus X1, and gravity becomes a predator, devouring any matter that drifts too close to its event horizon. In the galactic graveyard, everything is held together by dark matter. It forms the glowing web acting as the universe's skeleton. But a competing pressure, dark energy, forces the galaxy clusters apart. It drives the universe to expand at an ever-quickening rate. Returning to this view of the Earth from orbit, the physical stability we see here is the true anomaly. The supersonic glass storms and lethal radiation we've explored are not rare exceptions. That level of physical chaos is the default state of the cosmos. By comparison, our planet is a staggeringly rare oasis, a pocket of physical stability in a universe defined by extremes. The silence of the night sky is the primary benefit of our isolation from the violent physical forces that dictate the rest of the cosmos.